Okay, so finally, welcome to Kopernik Observatory and Science Center for our one of our Friday night public programs this evening. We do have a full slate of spring programs coming up all the way through May 31st, which I'll show you in just a moment. Tonight is the Dynamic Eclipse Broadcast presentation with our Eclipse Science Team. So of the Eclipse Science Team, we have Sasha back here, Elle and Tyler, and also John, who could not be here today. So I'll let them fully introduce themselves a little later, but we'll have a part of our presentation for that. For now, let's take a quick look into Kopernik.org, where you can learn all about our events. Some major ones happening. In fact, just tomorrow, we're going to have our Race to the Stars, which is right here on our website. You can click that, and you get a whole bunch of information. It's not too late to register for Race to the Stars. You can't register online, but if you come in tomorrow at 6 p.m., you can do walk-in registration. So if you're a runner or a walker, you are welcome to explore that course. I can show you it here briefly. There you go. It's you go back and forth along that route that you're seeing on the map. And that should be that's always a very fun, engaging event. Usually we get around 70 to 80 runners during Race to the Stars. So 6 p.m. is registration, race starts at 7, and we have awards at 8. If the skies manage to clear up at all, we will be looking through the telescopes that day as well. For those who are here in person, the skies will be clear, so we will be observing outside through the scopes for primarily deep sky objects this evening. So you can always learn more about our clear sky chart at the bottom of our page. You can click for sky conditions, and you're looking for dark blue is what you want to see during the evening hours. So over here we have our cloud cover for this evening. All of it is even seeing is even pretty decent. So yeah, just after the program, we should be treated to some very nice starry skies. Okay, and last thing I'll show you on our website is our public programs coming up. We do have a spring schedule available out in the lobby if you want to pick that up on your way out, but you can always access it here. So we are here at the Dynamic Eclipse Broadcast. For those who didn't know or did not tune into our March public programs, all those spring programs were March to the eclipse, so eclipse focused. You can tune into those on our YouTube channel. But now this will be our last eclipse program, and then we're moving on to our variety of regularly scheduled STEM events. So next week is How Our Minds Learn the Sounds of Speech. We have Ringed Worlds of Our Solar System, Dinosaur Artifacts, Summer Skies, and this Science and Religion. That takes us to May 31st, at which point we'll release our summer schedule. So you can look out for that too. Just like we are tonight, and what took me a minute to make sure they got the right feed, we are streaming out on our YouTube channel. So we'll load that up. That's just called Kopernik Observatory. You can find us there and subscribe. And you can see this is streaming now, the DEB presentation. Down here we have all our upcoming live streams. You can see those map out to our spring schedule. And we have observing events as well related to our discussion tonight. You can go back and tune into some of our total eclipse live stream. I will say it was a little uneventful, a little spoiler there, as far as like communicating like we usually do with Q&A. We were just very focused on our job on site. But we did do a solar eclipse Q&A here, which you're welcome to tune in there as well. Basically we're going to give you an overview of what that was kind of like, what our experience on the ground was like, and tie it into our discussion on Dynamic Eclipse Broadcast. So without further ado, I'll close out of this, and we'll jump into our slides. Okay. So I don't think I've introduced myself yet. My name is Jenny Cardy. I am a science educator here at Kopernik Observatory and Science Center. And I was one of the co-leaders, a part of our Eclipse Science Team, which was operating under this Dynamic Eclipse Broadcast. So getting right into it, what is the Dynamic Eclipse Broadcast? The acronym does a good job of summarizing it. This map is displaying all the observing sites that are involved in DEB. And there's over 80 organizations that had the same exact rig, the same exact telescope and camera, computer system. So everything was standardized across the board, and our goal was for everyone to capture data during the April 8th total eclipse. So you can see there's even some observing sites that were outside the path of totality. So this line here, this arc, is the path of totality on April 8th. And most of the observing sites are held there. There are others outside that are strictly recording photosphere, or primarily photosphere data during the solar eclipse. So only in here would you get coronal data. I'll have a slide coming up that defines that better with an image. A difference between what's the photosphere, what's the corona, and the corona is only something you only get during the total solar eclipse. So if you visit the DEB website, you can explore this map in more detail with all those 80+ organizations. So coming down here, you can see there's some in Mexico, going through Texas, the States, up into New York, and there's a handful in New York. Oops. The zoom doesn't want to quite work the way I want it to, but yep, here's one right on the center line in Buffalo, Erie. Sometimes they tell you who it was and sometimes they don't. I think that was the Children's Museum in Erie. In fact, this whole project started during a workshop back in November where at least all the organizations under our particular group of DEB came together and got trained on the equipment, got trained on what they're expecting of us, and that was held at the Great Lakes Science Center, which they had their observing set up there as well. If you have not been to the Great Lakes Science Center, I could not recommend it more. It's a very nice place and very accessible as far as driving into it from the east here. It's like right off the highway, really easy to get to. Now our observing site was here in Oswego, and we'll have a picture of that to show you in more detail and some video footage from the site as well. And you can go up into the northeast here. There's someone in Plattsburgh. And what's really nice about this too is that you can explore some of the images that were uploaded during the event. So let's try that. We'll start down here at Great Lakes Science Center. So there you go. There's the last photo that they uploaded in Cleveland area at their observing site. And actually, they might even have a total. Oh, no, that did not upload. But you could go through and explore every single one of these. So the cards that I'll offer to you, I'll show you them in detail in a minute, but though you can take one of those home, one per family, and that gives you greater detail on what this map is like, what the DEB initiative is like, and of course you can visit their website, DEB Initiative. And this is their site where you can always learn more about them. They'll have the map here too, so that's debinitiative.org. So yeah, in summary, it's capturing the eclipse event at all stages, and regardless of weather conditions, regardless of whether you're in totality or just have a partial eclipse, these sites were committed to uploading and collecting that data during the eclipse event. Okay. Again, there we go. So that's DEB, and there's some important science goals associated, because like, okay, all these organizations are collecting this data, all these 80 plus, and they're getting this huge library, this huge data set to pull from. And these are the three highlights, the three science goals that they have. They're collecting, for us, this was what we were seeking, collecting coronal observations during the 2024 total solar eclipse on April 8th. There was also the chance for previous DEB. Some of the sites got up and running during the annular eclipse on October 14th of 2023. So their goal was collecting solar and lunar limb observations during that eclipse. That's the Ring of Fire eclipse, which we also did a stream on. I'll leave Sasha to discuss that a little later. We did get to observe that, but we weren't quite involved in DEB yet. Then collecting data from a variety of day and nighttime objects. So part of our practice sessions included observing the moon, and so that was one target, but even afterwards, they're planning to open our rig up to additional targets, including deep sky objects. So that is very exciting that this has the potential to continue on. And this is all citizen-driven science. So we were lucky enough to get access to this program through another organization. But in general, universities were welcome to the program, science centers, and so forth. So before we move on to that next section of our eclipse team, so DEB is one part of it. I just want to quickly explain why study the sun during an eclipse. So this is a phased view of the solar eclipse event from April 8th. So this was from Dallas, Texas, I believe, that NASA pool got this imagery from. And you can see the partial eclipse. And this is the moon, starting to the new moon, passing in front of the sun. And as you see, it moves further and further. All that motion is driven by the moon's orbit around Earth. So that's what you're actually noticing if you were able to watch the eclipse where you were, or if you tuned into live streams. It's going through these phases because the moon is orbiting around our planet. And so you're seeing that motion as it passes in front. Okay, so it covers up more and more. You get this, starting to get this thin little crescent. And then totality is when the moon fully blocks out the sun. So no photosphere. The photosphere is the surface of the sun that you're seeing through these filtered images. You're not seeing any of that surface of the sun anymore. You're just strictly getting the solar atmosphere known as the solar corona. And that's what's especially powerful here. Total solar eclipses are the primary way to study the inner corona. So the solar atmosphere has multiple sections. You have inner corona and outer corona primarily, and that inner corona is what's observable during these total solar eclipses and what you want to study. It is possible to observe the outer corona during like some of the solar observatories. They will explore the outer corona, those that are out in space, stereo A and B. They are able to block out the sun enough so that they can capture the outer corona. But it's really the inner corona that is important here. And it is observable from the surface of Earth. So that's what we like to see. And then after, you continue on through the phases as the moon passes in front. So the partial eclipse lasts a lot longer. The event on April 8th was 2.5 hours in total. For our observing site, we were dealing with about 3.5 minutes of total solar eclipse. So that this part does not last very long. So studying the solar corona, but also the surface of the sun during solar corona. Those were the primary objectives. And what was neat about this past solar eclipse is it's also happening during solar maximum. You may have seen in the news that the sun just sent off, I think it was like 4 almost simultaneous flares, and that's a sign of all that activity. Right now, the sun is speckled with sunspots. It's very active, and so it was even more paramount to be able to collect all of this data during this eclipse on April 8th because it synced up with a maximum. So DEB was really the science side of our eclipse team. And the other component was Einstein's incredible universe. And this is both the name of a full dome show on Einstein's life and also the impact he had across science. And it's also the same name as the project that we fall under specifically. So not only are we a part of Dynamic Eclipse Broadcast, but we're also a part of Einstein's incredible universe. So there's this engagement perspective that EIU is taking critically to engage young students into STEM and to introduce them into those, in this case, a topic in astronomy, but to get them used to using high-end research-grade equipment and software. I shouldn't say high-end. This is like accessible equipment. So even you could, with the right gear, you could be collecting data like this. So that's Einstein's incredible universe. It is sponsored in many different ways. You can see Great Lakes Science Center there, Southern Illinois University. That's where the science side comes from, DEB as well. National Girls Collaborative Project. And the Cosmic Picture is the producer of this full dome show. So Cosmic Picture actually went out to one of the observing sites. I haven't heard word who they went to. I think it was at Great Lakes Science Center because it turned out their skies were going to be clear. It was very iffy what direction that was going to lead, but I think that's where they ended up, and they recorded the reactions to the eclipse event, both from the group that was there studying the sun with their rig, but also the public interactions as well. And that's something that's going to be brought into this video. So if you ever, I think they said maybe around 2026 is when it would be finalized and release. So you will have the opportunity maybe to see this film in the future. And the other big tie-in to this, if we're relating DEB, the science side, the engagement side for the eclipse and outreach, and we focus and narrow in on Einstein. Einstein's theory of relativity was proved using a total solar eclipse because it's only during that time when you're blocking out, when the moon's blocking out the sun, that you can capture the stars around the sun. You can pick them right up in imagery, and you're able to notice that based on the star maps, those stars behind there, they are actually being bent around the gravitational well the sun produces. So that was a paramount evidentiary study that was done shortly after Einstein published his paper. So there's that direct tie-in there, and something that they are going to be emphasizing during that show. So that'll be displayed on big full dome projections, the IMAX style theaters or planetariums. Look out for that in the future. So that's what our group falls under, and I doubled up the two images there. I'm going to do this quick. But we don't. We want to get rid of one, and we want to bring in this one of you all hard at work. Okay, so for the Kopernik Observatory Eclipse Science Team, this is where it all comes together for us. So we've expanded out. We've looked at Dynamic Eclipse Broadcast, the science side. We've looked at Einstein's incredible universe, which is where we were given this opportunity, Kopernik itself, to participate in DEB. And through this, between the co-leaders, Sasha and myself, we pieced together a plan to engage with SUNY Broome and students at SUNY Broome. This was probably one of our maybe February practice, if I recall, when it was a nice, bright, sunny day. One of the first ones that we had were during one of our meetings. And so we really did do a great celebration in studying and using our heliostat, which is in the room next door in the physics lab. So that's solar projection. And you can see some sunspots here. And John here is holding up a quarter to represent the size of Earth with respect to this scale of the sun. And then they went outside after viewing that and went out with their rig to explore and collect their first set of solid photosphere images. So there was all this practice leading up to it. And we were meeting on weekends where they would learn the telescopes themselves. They would, it was really student-led and independent work was the goal of the project as much as possible. So we were both, Sasha and I were there for the troubleshooting aspects and things like software updates that they would roll out. But yeah, it was really the team that made this happen. So that's a view of some of the lead-up work. And the equipment itself, like I mentioned earlier, the rig for Dynamic Eclipse Broadcast was the same for every observing site, so that there was some level of standardization for that big, large data set that they were utilizing. So down here was the only exception to that rule. I think some of the DEB sites outside of Einstein's incredible universe may have switched out their mounts, but otherwise telescope, tripod, camera system, and even laptop, those were all the same across the board. So let's just quickly go through what the rig is like. We have an Asker FMA 180 sextuple APO refractor. So that's a 6-element lens. That's the scope that you're seeing up there. And a refractor telescope, so lens-based versus reflectors, which are mirror-based. So this is a nice wide field telescope. Then the Ioptron Sky Hunter, which is the mount chosen for this project. And there is definitely a significant learning curve, and the mount itself had some, you had to dial it in very specifically to get it to track how it properly, to not have it slip. Primarily that was due to the clutches themselves. But that just presented a challenge for the group, and I commend them on utilizing that mount. Then we have the Player 1 Neptune N monochrome planetary camera. So that's what's capturing the disk of the sun itself, and then eventually the eclipse, both partial and total. So a small sensor on that camera, and only one color. So you do get a black and white feed out of that display. Then the polymer solar filter, which is pretty much the same material that your solar eclipse glasses that you may have used on April 8th. Same design there. And then the Ioptron tripod, which is just the nice sturdy tripod, at least for this rig, that they utilized. And then the imaging program, the software we were using was SharpCap, and DEB designed a whole script or set of scripts that the team used for photosphere capture, for totality, to capture flats and darks for processing later. And that's all there. So they did a lot of the software side work for us, and it was a process of learning how to utilize that software that they provided. Okay, so where did we go for our solar eclipse viewing, for our observing site? Well, we weren't going to stay here because it was a partial solar eclipse. It was a deep partial. It was 97% of the moon covered the sun. But that's not good enough to give you a total eclipse. So if you had the chance to see it here, which again, given the weather, I don't think many did, but if you did, it was just a very thin sliver of sunlight left behind, where you still needed to wear your eclipse glasses to view it. No total eclipse there. So we wanted to make sure we were capturing coronal data as well as the partial eclipse. And it is just so accessible. We just had to travel up to Oswego in our case, but you could even travel to Seneca Falls or to Syracuse. There were a good few options that were even within an hour's drive or so to access totality. But we went a little further north to get us that much closer to the center line. The closer you get to that path of totality that we were seeing in our image here. That pink line here is the center line of the path. And the closer you get to that center line, the more time you have with totality. So like in Syracuse, in northern Syracuse, it was about 2 minutes. In Oswego, it was nearly 3.5 minutes. And that's significant. And even more significant when you're dealing with like cloudy skies, for example. So it gives you a better chance of viewing. There we go. So we ended up at Rice Creek Field Station, thanks to Dr. Kabur, who has a YouTube channel as well, Pompeii Observatory. And he does a lot of live streams, observing live streams there. So that's how we connected, was actually we both do similar things. So we were able to get a spot reserved there for us at Rice Creek Field Station. And that's SUNY Oswego's science field station. It has an observatory there as well. It's a really nice facility. So if you're ever able to explore that, I recommend it. And it was a ticketed event too, so that meant the crowds were going to be more controlled and everything. It seemed like an optimum place for us when we're very careful about our rigs. You can see how many telescopes are laid out here, not just from our equipment, but also from other astro societies that we're visiting that day. So like back here in the corner was Syracuse Astronomical Society, and these were their scopes here. Nope, this one here. And then our rigs are here. So you can see that the DEB rig right there. So that's where we ended up, and I want to thank them for letting us use that as their observing site. To that end, we are going to move into this experience report section, which is going to be a breakdown for each of our experiences on that day of the eclipse, how we felt about the event. At least now I'm speaking from my perspective of what I'm going to share, but it may vary. So how we felt about the event, maybe some imagery from the event as well. Okay, so we're going to start with myself, and I have a video to show you here. This was captured from the 360 camera we had on site, which we'll see some more footage from that a little later. But you can see the Rice Creek Observatory here, right in the center of frame. So with a 360 camera, we were able to frame up this shot to kind of show you myself and my reactions, but also the kind of flyover of the shadow during the total solar eclipse. So let me just share with you before I even show you this. biggest takeaway from our event, I guess arguably, is clouds. We experienced clouds that day. It started off with partly cloudy blue skies on the journey there, and then proceeded to cloud up as it got closer to the eclipse itself. So that was like the baseline experience. Okay, it's cloudy. What does that mean for us, and how do we relate to that? So I'll save some of the data capture from this telescope. This was the C star that was running the live stream. I'll save some of that for later. I have a little time lapse that you'll see. But yeah, for now, let me play the video, and then I'll share my actual thoughts that we experienced. And maybe audio won't play at all for us today. Oh, that's why. Huh. So this is at just before the moment.
Good night, guys. Wow. Totality! Wow. Look at that. Oh, oh, there's Corona breaking through. There's some light there. There's some glow there. Did you see him, Morgan?
Yeah, were you seeing it?
Yeah.
Do you see it?
Look right there, right there.
Yeah. Like, it's just like, I see like a ring.
Okay, so that was the eclipse experience. There was a little bit extra, which you'll see in the next, when we show you some of the 360 videos. But there was it started out, like you heard all the excitement, especially as that darkness approached. That, for me, was certainly incredibly exciting to observe, to see the sky. It basically turned into twilight, or a near like moonlit sky. That's how best I could approximate it through the clouds. Significantly dark, and I don't think the video totally does that justice. You can see it get darker. You can see the light come on around the observatory. But even then, like how your eyes react to that dimming of light is completely different compared to what a camera is doing, which is trying to capture as best it can and expose for all values around it. So significantly dark, hearing nature react around us too was pretty incredible. Hearing the birds start to realize something different is happening. I think it may be time to return home, and so flying back to their nest. There was a lot of bird activity. For what bugs were out at this time of year, you could hear some. I think we did hear maybe some crickets chirping. It was like a switch into night mode, and so they actually had another citizen science project going on there too, listening for the acoustics of the eclipse and how certainly how humans were reacting to it. I'm sure they collected some of that, but it was targeting biology. How was nature at Rice Creek field station reacting to totality. So that's like the observable experience. That's the, I guess, like my scientific take on it, and resulting enjoyment from that.
Can
If,
I make
yeah.
one note here? I was lucky enough to be in Tupper Lake where it was totally clear. And of course, all the stars came out and you could see the planets and everything at the same time. But the thing that maybe you experienced, but we definitely did, was in 1 minute a 20-degree temperature drop.
Oh,
it just went from being dressed like this to you had to put on winter coats. And it just went straight down.
Yeah.
It was totally amazing. Probably because we had bright sunshine before that.
Yeah, certainly. The temperature drop was noticeable, approximately where we are. I wouldn't say, at least for me, I didn't feel like it was that dramatic, and maybe that's just due to insulating effect.
It's probably because of your clouds that
Yeah.
it made it less so, but in a place where it's clear, it just plunged, and it was a dramatic. It was 19 degrees or so.
Sure. Yeah. So that's certainly valuable. So yeah, the temperature drop was another significant impact that we did feel. But now speaking outside of that, because this I think for everyone, this is a personal experience. So in my case, how did I react both during and after? So for one thing, you can see probably the most significant moment was in here.
Oh, there's Corona breaking through. There's some light there.
This was further ahead than I thought.
There's some glow there.
I will also say
Did you see him, Morgan?
so to specify what happened in that moment, that was the glimpse of total eclipse. For most of this video, the total eclipse is happening. As soon as the sky gets perfectly dark, the eclipse is behind those clouds. But that moment was our maybe 1 to 2 second view of the total eclipse, where we did get to see the corona. We got to see that darkness of the moon there covering up the sun. It wasn't, obviously that's not going to be in any high level of detail, but we saw it. We saw it in that moment. And in the end, that was certainly the primary goal of Einstein's incredible universe, was to welcome the chance to observe the total eclipse, observe really any partial eclipse or total, and that's what was accomplished in that moment for all of us. We were able to see that glimpse of totality. So that was impactful. One major takeaway too from this, and this isn't even necessarily to do with the total eclipse, that moment of totality itself, but kind of an overarching culmination of the eclipse event. So like here at Kopernik, one of our big drives over the last month or two was to reach out to the community and bring eclipse events and programming to you in preparation, leading you so that you know where totality was, where it's not, how to view and observe the eclipse safely. That was paramount for us to engage our community on that level. So it was fascinating, like after the event and the day after, the week after, to kind of just have that turn off. Like it's like a switch. And get, like, you can even look at Google Trends, for example. It's logical that this would happen. You can watch the spike of eclipse interest, and then it just plummets. There's some tapering off, if only because people are going to be looking up images and videos post-eclipse, but it really is like that build up, and then you just shut that switch off. And that was certainly my experience, is like, okay, we were doing that for a month or two, about a month and a half of constant eclipse programming, and then boom, the switch turns off. So that was fascinating to me. I wasn't anticipating that, kind of that feeling of purpose, I guess, and a very direct understanding of what our job was as an observatory and how to communicate eclipse science and safety to the public. So that was fascinating for me, for one thing. And second, what I've been telling a lot of people in my reaction to the eclipse event is that glimpse of totality was not enough for me. Even if it was a perfect clear sky, perfect total eclipse, I'm not sure if it would have been enough either. You know, I probably would have wanted to seek out a total eclipse again in the future. But just that second of totality was enough to be like, okay, we're going to continue this throughout the rest of my life. We're going to go searching as best I can for total solar eclipses, because the partial eclipse is one thing, but yeah, the glimpse definitely inspired the want to continue, and it also inspired and fueled my continued interest in astronomy itself, and continuing to explore that field. We're no stranger to clouds here at Kopernik. Thankfully tonight it's going to be clear. So like that's part of the experience and part of doing our best to enjoy the event. But yeah, I'm excited to look out for it in the future, whether it be out in Greenland and Iceland and Spain, and that area is the next one. In 2028, there's a good one in Australia, stretching across that country. So there's some good opportunities coming up for travel. And then, of course, 2045 is the next good one through the States. So yeah, opportunities for sure there. So with that said, that is my experience. Now I think it's critical that we bring it to, we're going to go to Sasha next, one of the co-leaders on the project, and then to our team members. And we're going to watch this again. Okay, so I will pass it along to Sasha, and Sasha needs this microphone here. I'll mute myself.
So I'm Sasha Zaleski. I was one of the co-leaders with the DEB project, and I kind of helped the team a lot with troubleshooting our software and hardware. We did have some issues with the mount on the day of the eclipse. However, our team managed it incredibly well. We figured out some solutions. Unfortunately, the weather wasn't as cooperative. But I did want to talk about kind of my experience with the eclipse as well as what I was involved in. So prior to the DEB project, I was actually part of the NASA Partner Eclipse Ambassador program, which was a program designed to kind of bring knowledge about the solar eclipse to underserved communities. So if we kind of go back, there was a live stream that I actually traveled to Texas to see the annular eclipse on October 14th. Unfortunately, I was in an area where we only got a partial, so I didn't get to see annularity, but I did get to see a partial, and it was actually my first time seeing a solar eclipse. So Texas was my first experience, and there were quite a bit of differences between this eclipse that most recently happened as well as the one in Texas. And mostly, I would like to talk a little bit about my experience with both of them. Because in Texas, it was my first time. I wasn't sure what to really expect. And I was thankfully really lucky to have very clear skies that day. And one of the most noticeable changes was actually that temperature drop. It was pretty interesting to experience, since Texas, you typically expect warm weather. So it got progressively colder and colder and colder, and I actually had to pull out a sweater at some point due to how cold it actually ended up getting. And that wasn't even full coverage. Now the sky did get pretty gloomy. I think I'm so used to the weather being gloomy here that I didn't quite notice it until right near maximum. That image right there was actually taken with the telescope that I was streaming with at the time. I was using a ZWO camera, and the top images were taken with my DSLR, actually. So you can also see the progression of the clouds for the April 8th eclipse. But for additional kind of things I've noticed, I like to observe with all my senses. That was something that was encouraged to us in the Eclipse Ambassador training as well. So I really wanted to pay attention to what was going on around me and not just what was going on in the sky. So among the temperature drop, I also started hearing some differences. There was kind of this eerie silence that ended up taking over. I didn't hear any crickets, nothing. It was just completely quiet. All the animals went silent. I swear even the traffic somehow got more quiet. I have family in Texas, and they had 2 little dogs who kind of started freaking out and didn't really want to be outside. So that was also something I noticed. But when we were experiencing the April 8th total solar eclipse, it was a bit different. I had never been able to experience that kind of darkness before. With an annular eclipse, you don't really get that no matter where you are, that complete kind of switch to nighttime. So we had a presenter a couple months before that mentioned that even if it's cloudy, it's worth traveling to the path of totality. And I have to say I completely agree. Even if we didn't really quite get to see the solar corona in its full glory, it was still really worth it to be able to experience that, and I had a pretty emotional reaction to it. It's just really amazing to kind of notice these changes. It was cloudy, but you see it getting really, really dark. And I agreed that I didn't really notice quite as much of a temperature change this time as I did in Texas. But some of the things I started to notice is we were near water, and there were frogs that were croaking the whole time. And they ended up going really quiet. And eventually the frogs were replaced by crickets. And I did get a chance to take a quick walk around, and there were actually flowers that had closed. So you kind of see a lot of nature changing around you as you approach totality. And in that moment of totality, even in that very, very deep eclipse, there was still a substantial amount of light coming through. So it was almost kind of like this immediate switch to darkness. And there were like street lights that came on. Thankfully, when they were turned off, everyone cheered. So that was nice. But it was just a really, really amazing experience to see. And as the eclipse progressed, you see kind of this sunset form around you, all around, this kind of pinkish, orangish light. And that was really, really neat to experience. And I definitely want to have the opportunity to see totality with hopefully clear skies. So just like Jenny, I hope to be able to travel. My hope is either Spain in 2026 or 2027. And hopefully I could have the chance to experience totality, and I hope many of you might be able to have the same opportunity. It was really just an amazing experience, and it definitely makes me want to go chase more eclipses for sure. And I think we are actually going to switch over to Tyler's report right before.
Hello, everyone. Apologies for the change in order to the end. Speaking frankly, I couldn't take the pressure of going last, so thank you for agreeing to change. A bit of personal background. I've been interested in space and astronomy since I was a child. I remember having many long conversations with my father about the stars, about the solar system, about the galaxy, black holes, and the vast expanse of the universe out there. I remember as a child coming to Kopernik Observatory many times, sitting in this very room, wandering the halls and all of the interactive exhibits, here. As I grew, my interests grew to other places as well, but I've always kept one eye towards the stars, at least. So when I got the opportunity at the end of last semester to join up with this Eclipse Science Team, it was amazing. It was a dream come true, a dream that I never really knew that I had, but it was great. It's the second solar eclipse that I've seen. Back in 2017, there was a total eclipse that passed the United States, but I did not travel into the path of totality. I simply viewed that from home. A bit more than 70% coverage for that one. So this was the first time I've ever seen a total solar eclipse for real. And it was an amazing experience. It was something I'm very glad I got to do with the people I got to do it with. Personally, my report is going to be more about the experience of working as a part of this team because for me, that was the biggest takeaway. These people that I'm here with today are phenomenal, quite frankly. Elle, I met last semester in our shared astronomy class. Sasha, I met through Open Science Club. John, who unfortunately could not make it here today, also a valued member of this team and a great friend. And Jenny, who I met as a part of this, she's amazing. When I grow up, I want to be just like her. It was great getting to work with this team. Truly one of the best experiences of my life. When we started, we found our roles quite easily working with the equipment. I personally handled the setup of the telescope itself a lot, fitting the adapters and the camera and getting everything just right on that. Elle took over with a lot of the setup of the mount, the alignment to true north, making sure all of that was set and level and exactly where it needed to be. John handled a lot of the balancing, and we've mentioned the difficulties we had working with the mount itself, and getting those clutches to clutch really was a full person job. And then of course Elle and John split a lot of the responsibilities of working with the software, making sure that our observations were coming out as they needed to on the computer. So all of us found our roles very early on, which allowed us to focus in and really learn what it is we were doing. We were running by probably the third or fourth practice meeting as a well-oiled machine. During one of the conference calls we had with many of the other teams, apologies, we found that our team had one of the fastest setup times of any of them, which was, you know, a small little bit of pride that I think we can take in ourselves. We worked for 3 months to learn our roles and learn our jobs and get everything together. And on the day of the eclipse, we did, I think, a fantastic job. We got set up very early. We had some technical difficulties even in the lead up to the eclipse. At one point, our mount refused to continue to track the sun, but we managed manually, just moving very occasionally and bringing our view back into focus of the sun itself. Unfortunately, yes, weather did play a very important role into our project. It prevented us from getting the observations that we wanted to get, the observations that we were longing for in the many months leading up to this. But we learned a lot. We learned how to work as a team. We learned how to use the equipment. We learned a lot about ourselves and each other and about the world that we live in. And I think that that is incredibly valuable. And I'm very proud of everyone. I'm very glad that I got to be a part of this. And I mean, what more can I say? This has been a phenomenal experience, and thank you all. Thank you. And now to hand it over to Elle, who's going to give her experience. And is it the left arrow here? Is it? How do I go back on here? On the laptop keyboard. The other keyboard. All right.
Hello, everyone. My name is Yelizaveta Yatsuk, which is a mouthful, so that's why we call me Elle. I'm going to cry absolutely after hearing your report. I did not hear that beforehand. It was so wonderful. But how did I get onto this team? How did I start with astronomy? Goodness. So I have been in college for 2 years, and I was on track to be a psychology major. I was almost done with my degree. And then I made a decision to take an astronomy class, and I'm now suffering over math problems at 2 a.m., crying, absolutely, but I'm in love. Because when I went to this astronomy class, I started learning about the universe and my place within it. And I remember there was this one day when we were learning about star evolution and star death, and I was just sobbing at that point because I finally understood what Neil deGrasse Tyson meant by we are made of stardust. And I'll get into that a little bit later, but I remember going up to the professor afterwards, and who is not here, by the way, and I am going to be talking to him afterwards, but you know what? It's okay. But I remember going up to him afterwards, and I point to the board, and I say, I'm going to do this for the rest of my life. How do I do this for the rest of my life? And now I'm going to go into astrophysics. And that is that. And one of the biggest things I'm noticing, actually, about astrophysics and just STEM in general is the ratio of women to men in STEM. My physics class alone is composed of just 4 girls in the midst of 20 people. Being able to participate in a project promoting women in STEM is so rewarding, and I'm so happy that I got to do this with my friends. And now imagine my dismay as this amazing scientist girl boss hoping to change the world with her research when we couldn't get much at all. Whether the technical difficulties or the clouds, it just was not happening. I have felt heartbreak before, but this was different. This hit something inside of me that trembled at the core. And it was in that moment, when the sky turned to set and the frogs ceased their orchestra, that I felt truly, amazingly, terrifyingly human. When is the last time that you felt the beat of your own heart? I'm going to actually make you guys do this now. Go on, try it. Feel the beat of your own heart. Put your hand on your chest. We tend to forget it, don't we? In the midst of chasing goals, worrying about relationships, or even what to have for dinner, the sheer amazingness of our existence, how we are all just a collection of atoms that if picked apart one by one would just be a pile of particle dust, but put together we are here, and we are alive, and we get to experience this whirlwind of a thing we call life, and a thing like solar eclipses. And these atoms, I can stand here and rant to you about them all night if you give me the time, but I will never be able to describe how truly, amazingly, and terrifyingly it is that they exist. All I can say is that it took billions and billions of generations of stars to explode, and billions of times. And only with their sacrifice are we here today, feeling and thinking and breathing. And only because gravity is not too strong and not too weak, and we are neither crushed into a ball nor floated far enough from one another to be here at all. And if the ratio of the electromagnetic force to the strong force wasn't 1%, life couldn't even exist to begin with. How absolutely rare it is that we get to exist. And that we get to be here today, with me having the opportunity to rant to my fellow humans about how the universe was created just for you to be here listening to me. Feeling the beat of your own heart, watching solar eclipses, chasing goals, worrying about relationships and what you'll have as a midnight snack when you go home today. All the while with me just hoping that when you look up at the stars today, you'll know that they were made just to be seen by you. This universe was made just to be seen by you. Thank you.
Thank you so much, Elle. And thank you to all of you. Let me double check. Oh, Sasha, could you correct the camera again? It keeps bouncing back to when you guys go back to your seats. But thank you so much for all 3 of you from speaking from the heart and sharing your experience from the eclipse. Because it's pretty, I think, across the board. Everyone on that at Rice Creek Field Station, everyone across the path of totality, and even into the partial eclipse, everyone had this very personal experience. And I thank you so much for sharing that today. So, and I also want to express, too, I was looking forward to hearing your thoughts on the eclipse and on the team. And I thank my co-leader Sasha and Tyler and Elle and John for participating in this project. It was certainly a new experience for me, and a new experiences for them too, to organize this style of team and engage with this the set of organizations that under DEB at least reached as 80 plus under Einstein's Incredible Universe 20 organizations. It was a big project and a big effort across the board. And yeah, thank you so much for being a part of that. So yeah, jumping from there, I do want to share some of the data, both from the rig itself. That's what we'll start with first, and then we'll jump into the C-STAR telescope, which was our live stream scope. And I'm realizing I don't need this mic anymore, do I? I can switch over to my lav. Okay, so we'll turn this off for now. And that's on. Okay, so the eclipse data from the DEB rig, that's the scope right up front. We have 3 shots. This isn't all the data, but given the sky conditions that day and how variable it was, these are the select shots that the team chose based on image quality, based on sky conditions. And we start with just our first initial view of the sun. Again, all monochrome. So you're just getting a black and white image here. And you're seeing the sunspots on the surface there that day. I'd say surprisingly quiet, especially considering the eclipse, or not the eclipse, the sun today, or this week. You see it's speckled with crazy sunspots all over. But yeah, surprisingly quiet here, except for this big, Earth-sized sunspot there, larger than Earth. Then in the middle here, the eclipse has started. You're moving into that partial phase. And those sunspots are obviously still there. You're seeing some stacking artifacts, again, possibly due to those sky conditions. These images were assembled from several stacked together. This was all done in the software they were using, and it did so automatically. So it stacked them. And you can even see it's around the disk of the sun. It's starting to get a little hazier. And then the third image is deeper into the partial eclipse. And really hard to make out the sunspots at that point. The scope is in focus, but hazy weather at that point. So you can see the actual process, how it, just in these 3 images alone, how the conditions and how the view of the eclipse reacted to those waning conditions. And at a certain point, too, it was pretty, just to, I guess, share another experience from the day with all the astronomers and amateur astronomers and people on site using equipment. Every time you got a slight clearing in the sky, because it was really back and forth with the partial eclipse, everyone rushed up to their rigs to take that moment to recenter the view, because tracking is not going to be perfect, especially if you're setting up on the day of. It's really hard to dial that in to get perfect alignment. So every time there was that opportunity, everyone rushed up to their scopes and their rigs. So that happened every time, and is up to this point in the sky, or rather I should say after this point, it was getting cloudy enough where we weren't getting long enough breaks in the clouds to be able to do that same thing. And if you watch the live stream that day, you can see that moment happen. At a certain point, it's just, you get these brief glimpses, but they're not long enough to recenter. They're not long enough to capture any valuable data. And so this is a good representation of after this, really challenging to keep the scope centered and capturing. All right, so I have a time lapse from the C-STAR S50 telescope, which turned out to be a wonderful solar telescope for our use case on the live stream. It kept center so well, and you'll see here with the time lapse how stable it is, even with all these clouds. Like it was really stable throughout. It did require some adjustment of exposure, so actually right there I'll pause it back here, because there is this moment where things are pretty clear, and you're seeing some of that spot structure, and then it carries on. See back and forth for a while, but you can tell it's like kind of a decay. You get longer and longer periods of cloud cover as the eclipse carries on. And yeah, eventually we get about just under halfway of partial eclipse, and then this telescope became a light meter. It just was tracking the brightness of the sky, which is still pretty neat to see this. Ooh, there it goes. There's totality, darkness, and then back, brightening up the sky. I think there was maybe like half a frame. Oh yeah, there, look right there. So that's post-total eclipse that we were able to capture a brief moment of the disk of the sun and the partial eclipse. So well, let's just let this play out. I don't think we get much more of that from there, but you do see the view brightening up again. So that was our experience. It really did, like, at least for our site and a lot of areas in that region of New York, it was like kind of a case of clouding up at the worst time. And of course, if you're aware, both both Sunday and Tuesday were pretty decent. It was this window for the eclipse that was, and that's obviously, it's just happenstance, it's coincidence, but still, the brain can't help but ponder that. It's like, oh, why? Okay. So then I do just want to quickly jump to the Eclipse NASA site, because it's a good resource to find some imagery from the event. Here's this image here that we looked at earlier to talk about partial versus total. There's this clip, which is the crowd reacting in Dallas, Texas. Yeah, you can watch it. Let's see what it is.
So that is where the sun will be correct. That will turn into a diamond ring.
I can't describe this adequately. It feels like nighttime. It feels like total nighttime.
So there's some locations that experience clear skies. Scroll down here and get this time-lapse view. Where is this from? Well, this is in Dallas too. So yeah, I mean, earlier on in the forecast, Texas was looking worse than New York for a time. But here, look at that. It's kind of the opposite. It seems to get clearer right around as totality approaches. And then, yep, there are the planets. They're pointing out the planets. Here is a nice view just after totality, it says. So totality is wrapping up at this point. In a lot of astrophotos we've seen, there's this major prominence, which I believe from the reports I've heard that was visible to the eye. Were you able to see that, George?
Yes, and also, and we use binoculars doing that, so that's pretty much what we saw with binoculars.
Okay.
But I had an H-alpha telescope for people who don't know, that's looking at one wavelength of light from hydrogen, so I could see all that detail during the partial phases, and I could see those prominences, And you're right, the two sunspots were pretty disappointing. There was only two, but there were bright plage areas, and there was a lot of dark filaments, which are those prominences on the disk across it. So it wasn't as bad as it looked like in photo. But
Gotcha.
seeing all this, I was one of the luckiest people in the world, because the whole central Adirondacks was just perfectly clear.
Oh,
For
amazing.
about a half an hour during it, so you couldn't have better skies.
I'm certainly glad that for Tupper Lake and elsewhere in the Adirondacks that all panned out well.
Also, NASA had one of its major feeds there, and they had a screen, a building-sized screen that they were projecting their live stream on.
Oh.
I was in a different part of town, but it was like at least 30 feet long and 15, 20 feet high, and they were projecting on that, so the crowd could look up and see it.
Very
They could
nice.
also see the telescopic view being projected on that screen also.
Yeah, it sounded like their event really came together, and the weather behaved in the end too. So fantastic. There's just before total eclipse from the SDO Solar Dynamics Observatory. There's a view from above. Is this on the ISS? Yes, it is. International Space Station view. There is the shadow of the moon passing across Earth, and that's from EPIC Earth Polychromatic Imaging Camera. So a nice high resolution satellite view of the eclipse event. Kopernik did actually pull down from some data from the GOES satellites, capturing a similar view, but from what I was told, somehow someone stepped on the Raspberry Pi system that operates the pull down from that satellite and actually assembles the imagery and processes the data. So it cut off, but we got some of the shadowing, which is pretty neat from that GOES satellite. Oh, there's a nice composite there of the partial to total to partial. So that's a website worth exploring. Oh. So yeah, just to conclude things here before we get to that last slide, like I said, I had a 360 camera going. So what we're going to do is we're going to expand this, make sure I'm on the right one. Well, yeah, we can show the setup one here. We won't show it all, but if I zoom out, you'll see everyone, not just, oh, there I am, setting up the camera. You can see everyone working hard, like ants to get their rigs going, and I think if we skip to this point, is this where it was? We took a food break. We had to fuel up, so that's there's our group eating. And more importantly, I think, is that we do this view here to capture the entire sky at once. And if we go back to the beginning and scrub through, there's a nice solar halo through the clouds there. That's something. You can see the cloud cover and how it behaved over time, leading up. There's no totality in this video file. Oh, there's the drone. There's your drone, Sasha. And you can see it got cloudier and cloudier as we scrub through. Some moments and windows of blue sky. Then we can go to our view of totality, which I think started with this one. So towards the end of this clip is where we get totality. Yep, there we go. So you'll see the shadow roll across the field of view there. If you play it back fast enough, it's just like a switch. Now there was a point here where the camera did just pick up on the little crescent peeking through the clouds right there. So you can see that tiny little sliver of sunlight just before totality hits. And the difference between that little sliver of sunlight and totality itself in the solar corona. The corona is not very bright compared to at all to the photosphere of the sun. So you're not going to see that breakthrough like this crescent of sunlight. That's why it just turns off behind the clouds there. And there was a moment eventually where we saw that glimpse, but the camera didn't quite pick that up. So obviously this is a very wide field. And then this is in totality and then moving out of totality. You see that light, that very distinct cutoff of the total eclipse's shadow. All right, and then the clouds pretty much stayed consistent the rest of the day. There really wasn't much breaking through, at least in the time that we spent remaining there to put all our equipment away. So that's an overview of our eclipse experience. There are, of course, plenty of places to go online to explore the eclipse event, and of course DEB as well. You can go to that website and explore the imagery that were collected by our other organizations. Got one more slide to show you in just a moment, but I also want to make you aware of the items that you can pick up on your way out if you like. We have some stickers left for DEB, so you're welcome to take the logo for the Dynamic Eclipse Broadcast. We do have a map, and there's QR codes and more information about DEB. You're welcome to take those. There's this nice placard of what was out during this total solar eclipse. All the celestial objects around it, planetary objects, comet Pons Brooks was there in the sky technically, though not visible to the eye. And there's also a heliophysics NASA bookmark. So those are all items that we got through Dynamic Eclipse Broadcast, and you're welcome to pick those up on your way out. With that said, I want to conclude with, this was like basically our last moment at Rice Creek Field Station, and I think, yeah, this image, you see we're all smiling, we're all happy, at least as happy as we can be given the skies. We did get a nice recording with this Polaroid of those sky conditions being overcast. But yeah, this captures the team. Also, I want to thank Valerie Waters, who is my partner. She was there with us that day. And I don't think I probably could have gone through that trip without her. So it was very, she did a tremendous job helping organize this event. She's not here today, but I do want to thank her as well. So she's joining the team here in this image as, I guess an unofficial team member. But that's our Polaroid. I do also want to thank who took this Polaroid. It was Shane Johnson from the Syracuse Astronomical Society. They were set up right next to us, and they were kind enough to take this image with us. And I think with this is where we got our time lapse back during Astrofest. We broke a 50-year time lapse out of the wall here, and what was in there is in the back of the room in the glass case. So you're welcome to check that out. But we're starting to think about items that will make it into the next time lapse, that time capsule that goes behind our 1973 memorial plaque there. So this is going to be one of them. We're going to put in our this memory of the Eclipse Science Team into at least one of our 2 time capsules as a celebration of the 50th anniversary and what 2024 was like. So, yeah, I think that's a great place to leave off on. So, with that said, I'm happy to open it up to any questions, any remaining questions about the eclipse event itself. I will bring the mic to those that have questions in the audience so that the live stream can hear you too. And then we can also take any questions from the live stream. So, Mark, I'll give you the mic here.
As all the different stations start pulling their data together, are there any new discoveries about the eclipse?
Oh, so thank you. So I guess the thing about this data set that DEB has assembled through this project is that it's going to be used in a variety of studies. There's no immediate target study for its use. So for example, I know our team asked specifically what you're planning to study with this data set. And they came back, one with the idea that it's a collection of data. During this eclipse event, it's kind of a case of collect all the data you can first. It's going to be valuable. And then scientists have plans, however, at whatever stage, to start utilizing it. And then even beyond that, I mean, you think to the data sets that are captured from NASA spacecraft flying through the solar system. Those are studied for years and years and years. There's still new things being discovered out of Cassini and out of what's the other one that I recently read a study on? Oh, it was New Horizons. There was some data that they recently took another glance over, and so that data is consistently looked at, and that's what's going to happen with this massive data set from all those organizations. Is not just with the corona, but with the photosphere and the solar maximum, how all those things come together, and what studies can be done from them. So that's the plan for DEB's data. Any other questions in the audience? All right, and nothing on the live stream. Okay, so I'll turn this off. And yeah, with that said, we'll wrap up here. Thank you for those on the live stream for tuning in. And for those here at Kopernik tonight, we are going to go out to the telescopes to enjoy the night skies. We are expecting some nice views of star clusters, and while they're a little bit tricky to find, maybe some galaxies too. And we can even take either both of the rigs, or we can take them outside and capture some imagery of those objects, because the camera system is going to be able to show you a lot more than the human eye can with something like a galaxy. So that's where we'll go from here. Thank you for tuning into our Dynamic Eclipse broadcast, and let's give a hand to the Eclipse Science Team here at Kopernik. Thank you, everyone. All right. So feel free to come on up, and if you want any of the DEB items.